industry in Power Ledger project. I was work as a contributor to build energy tokenization. And today I want to talk about this part. Currently I work as a head of blockchain in the game company. We build AI cloud gaming with concept of a combination of AI and Web3. And currently I'm coming here to talk about one great area, renewable energy and energy tokenization. Can you hear me perfectly? Yeah. Based on I want to start about some different challenges that we face currently, climate action, climate change. As you know, there is some different challenge currently in the climate change section. For example, you can consider in a solar farm, a big solar farm that provide some different energy resources, but we have to solve some different problems in this industry. We have to instead of relying on one or two big investors to fund the energy, we can using the fractional ownership concept by using the digital shares of the token. This is the main important part and use case of the blockchain that you can use. In smart contracts are backbone of these structures. We can tokenize everything using the real world energy, renewable energy tokenizations, and each share of the energy is represented to its token. And we can create one marketplace for buying and selling. Actually, before that, Power Ledger or some different kinds of platform building something like this. I remember in Power Ledger we built dual token ecosystem for building each token was represented some part of the energy, and energy was tradable and traceable in our marketplace, and we're launching on the EVM ecosystem Ethereum. But currently, in terms of energy efficiency and scalability, that is one of the problems in the networks. There's some different solution for that. Layer 2 solution comes to solving this energy efficiency in this industry or sharding technology. And another problem is about the governments and regulations. As you know, we don't have clear regulation and rule exactly about the real world tokenization or something related to this part. If you are going for energy tokenizations, governments should provide and define clear rules about that. And another part is about lack of knowledge, and we have to use how users can use this type of energy for trading between energy consumers and energy resources. That's very important. I want to talk about some different parts of this process. As you know, if you think about the energy resources like solar, wind, or hydropower, we can see how we can provide this combination between tokenized and democratizing this process by blockchain. If you think by using some different simple concept that most of the platform currently trying to provide adoption in this industry using the standards for example on EVM compatible network using ERC 721, ERC 1155, or for tokens ERC 20, they can provide this adoption between real world traditional markets and the new tokenized ecosystem.
Well, I think there's many issues that need to be addressed. So I'm going to try to group them into various categories. I think the first category, I think you touch base, is very important, which is the category of regulation. So for you to be able to tokenize energy, you need to have a framework that allows you to do concepts known as security tokens or real world asset tokens. Not every country or every infrastructure allows that. So if you go to Saudi Arabia, that framework is not there. If, however, you come to UAE, there's something known as VARA that enables that. There's RACDAO as well. If you go to Thailand, SEC allows for such a framework as well. So you need to have the maturity of that framework. That framework takes time. You need to identify the amount of effort and cost that actually needs to take or do the tokenization. So for example, if you're doing that tokenization today in Thailand, we're talking about 6 to 8 months. So that's a very long time. I would say probably VARA today, you're talking 4 to 6 months. However, if you go to places like Germany, you can actually do real world asset tokenization in about 4 to 8 weeks. So that means you need to compress the time frame required that you become compliant with that regulation. So that is one aspect. The other aspect is the life cycle that you produce alongside that energy. So let's assume that energy is solar, hydrogen, or wind. As I mentioned before, a lot of these systems do not produce energy all the time. So sun only produces during the day if it's not cloudy. Wind only produces if there's wind, and so on. Others like hydrogen can produce more or less because if you have electrical system that can actually drive that infrastructure. So what that allows you to do is to create a complete system that gives you energy all the time. So we actually did, when I was in Huawei, a project in Oman for all the schools in Oman that was using solar to monetize it to the maximum number. And the way this monetization was done is that, as you know, the schools are not working all the time. So what they were doing was producing electricity all the time. When it was being used by the school, they used it for the school. When it was not being used, they were selling it back to the grid. In reality, the solar panels only produce 30% of the energy, but they actually produce 50% of the cost to the school. So it became a much more efficient mechanism. So that highlights the second element of regulation that is important. Not in every country you're allowed to sell back to the grid. Some countries allow, some countries don't. So if they don't allow to sell to the grid, then you have to create micro off-grid ecosystems. So maybe neighborhoods can create their own microgrid that is not connected to the main one and actually share the electricity that is produced using these mechanisms. Now back to tokenization. All these projects have one element in common that is very key. They're capital intensive projects. So sometimes you don't have the funding necessary for these projects. Sometimes the government does, but the government may not have that capability because liquidity or other. So crowdfunding through Web3 and through tokenization allows almost any individual to actually participate in that process. So for example, if you take something like solar panels, they're good for something like 10 years. The good thing is that today solar panels are quite efficient, especially the lower cost ones today can deliver electricity at about a cost of 4 cents per kilowatt. So that means the method by which you deliver electricity has to be either equivalent or lower than the grid. So for example, the grid today here is about 8-10 cents a kilowatt. So if you produce 4, it costs 8. It means people are willing to take advantage of that. So if people invest in tokens that then buy that infrastructure, they get rewarded with the extra benefits, which is the margin between the cost of production, 4 cents, and the 8 cents by which it is being consumed. So that means they get a return for the value of the tokens that they have purchased. So all these elements put together is what enables real world asset tokenization in the context of energy. The other element that we touched base a little bit is very important when I mentioned Permian chain, and they're tokenizing and creating a marketplace for monetizing energy. So the idea is they monetize any kind of energy, natural gas, electrical, wind, and so on. So the idea is you kind of create a market of who's offering the energy, who needs that energy, and then being able to do the match between the buyers and the sellers of that energy. And by creating these micro grids that enable the consumption of that, then you can actually monetize that energy. I give you two examples of monetization earlier. One is, let's assume you have that energy, but you cannot sell it because nobody is buying it. You can turn it into money, meaning that if you're generating Bitcoin, it is money. So you're taking electricity and generating money. That money sells the Bitcoin, pays back the token holders. You can also do AI, meaning you power the GPUs using that electricity. That GPUs are rented as a cloud service. Today, for example, the H100 GPU is rented at something like $5 per hour per GPU. So that means the server that costs something like, let's say, $300,000, which is again capital itself, so will produce somewhere between $20 and $30 a month of value as a cloud computer. Again, you're returning back value to the token holders. So it's all about the business model, meaning how you understand the relationship between where the energy comes from, how you make money with that energy. Either you make it by providing it to consumers, but if there's no consumers, you make an intermediate product that then generates value for the production of that energy. So how you optimize this? You create a whole new series of minor ecosystems. Another point I wanted to mention is you highlight, and I think is very important. One is blockchain. It makes the whole thing transparent, so nobody can cheat anybody. All the transactions are visible to all the parties. The second thing is the importance of automation. So today's smart contracts, which are kind of like stored procedures in the early days of databases, automate all the rules associated with how that energy gets monetized and how the various parties in the equation get rewarded. And they get rewarded in an automated way rather than through a manual way.
Awesome. Yeah, you're right. Actually, I can add some more things about the use case that you mentioned. For example, the RECs that you hear, the energy, the real world energy tokenizations, actually there's some different use case that is the real world applications that we can provide wide range of solutions and prove that energy is represent to the exactly energy resources. And based on, if you're going based on the blockchain, there is a transparent and there is no chance of fraud and everything going for transparently. That's wonderful things. And another thing about the carbon credits, that's very high currently. And exactly we are going based on the concept of smart contract for automation. All these process, as well as in the marketplace, we can provide the order booked market smart contracts to address these requirements for matching some different orders between energy resources, consumers, and some different people, and automatically doing this process. Exactly, you're right. And I want just added some different things about some part of the technology that we're currently using in the industry. As you mentioned, AI cloud computing, using some massive energy resources for that part. Currently, as you know, the Bitcoin concept and proof of work was not really great for the energy in terms of energy resources. But the new type of blockchain and consensus are provide massive potential for and the reduction in the carbon emissions. And currently, some different traditional companies working these and on these type of the carbon credits, and we can automate by the blockchain and use cases like traceability and transparency to solving and address these parts.
Well, for me, I see carbon credits as an extra reward mechanism. So if the energy that you're producing enables carbon credits, that means more returns to the token holders. So these are just an extra set of additional rewards. Now, these rewards obviously are only possible if you have all the documentation, because carbon credits is really about documentation. You need to say how you obtain that carbon credit and whether that carbon credit is certifiable or not. But if that carbon credit was properly obtained, it's properly certified, then you can issue it and sell it in the carbon marketplace, and any returns of value generation from that carbon sale or being sold, you give back as rewards to the token holders.
Awesome, right. Yeah, I'm thinking just you're right. Totally, energy tokenization certificates is one of that use case exactly you mentioned. I don't have anything to add this part. If you want, we can talk about the depin, digital physical infrastructure networks.
Well, depin has been around with us for almost 2 or 3 years now. depin is kind of a marriage of two technologies. On one side, we have AI technology, which uses massive amounts of physical infrastructure, and another technology, which is blockchain, which is a technology of trust and a technology of decentralization. Thus, the birth of depin, decentralized physical infrastructure. And by decentralizing that physical infrastructure, it means you're able to get rewards or obtain rewards or create value in a completely decentralized way. So there's many examples. One example is the first that I give about Permian chain, where you put the generation of value close to where the electricity is being generated by using flare gas or unconnected gas by creating electricity. But there's other mechanisms. We have a local organization here in Dubai that are creating small Bitcoin generation machines that don't make much noise and can be put at home. So for a few $100, you can buy those machines, you can rent them, so they generate tokens. So they are tokenized themselves. So it's another form of depin. So the idea is you'll be able to contribute as validators to the Bitcoin network or Ethereum networks, and then generate value for the token holders. So what this is actually doing is generating micro business models that allow you to monetize energy in different mechanisms. And then it's a question of which ones the users want to adopt. So what matters at the end of the day is which users want to use which tokens and which energy models. So the ones that have the most adoption are the ones that will become the most successful over time.
Right. As you know, with combination of AI and depin, maybe new era will generate in the future. Currently, AI agents trends it's very hype in the market, and most of the companies focusing this part. In other side, we have AI computing. Other side, we have a use case of blockchain and depin. Here, there is a I think in some part of the project, depending on the project, we have some combination between AI, this Web3 and depin. But how we can make it decentralized in depin?
It's actually very easy to do that decentralization. And this is what, for example, NVIDIA just released. By having these small footprint AI machines. You can distribute them across the network. You can connect them to the blockchain network, and they all work together to create a grid computer. So, for example, if you have a workload that needs to be generated in AI or to be treated, you send part of that workload to some of the nodes. Each one gets paid and rewarded based on the value they contribute to the AI model. They get rewarded. And then you have a decentralized mechanism of actually treating that workload. The important thing, we always focus a little bit too much on the GPUs. But to have a complete infrastructure, you need three elements. One is the GPUs. GPUs is only the compute. You also need the storage, so you need decentralized storage. So you need to have a decentralized mechanism in which the information that is used by the AI is also being stored, and it's being stored in a decentralized way. One example is like Filecoin. You have probably heard about it. It's not the only one. It's one out of 10 different variations. But what they allow, another one I know very well locally is called Threefold. It allows you to store that information. Or, for example, the other one is the Interplanetary File System, IPFS. So all these three are variations that enable you to have decentralized storage. The last one is also as important, which is decentralized networking. Because at the end of the day, you need to have the information, you need to process it to create. What you're doing is you're taking information and generating intelligence, but then you need to distribute that intelligence across the network. So you need to be able to monetize these three elements to actually have a complete solution, not just one of them.
Yeah. So you mean that we have something like a pool that's all some different type of AIs or something like this put their computing power in this pool, and another people can use this pool if they want, right?
That is correct. It's not any different than, for example, the pools that you have today for mining pools. And just instead of mining digital assets, they're actually providing tokenization of AI assets. So it means taking information and generating trained AI models. Now, there is existing marketplaces that have been created. One example is done by a good colleague of mine called Ben Wetzel. It's called Singularity.net. Singularity.net is one of the best examples where they've created a token that allows you to monetize your own AI. Meaning, I have my own AI model, I can list that model on the marketplace. It can be either untrained or trained model. If it's an untrained model, the user provides its data, trains it for their purposes. If it's already a trained model, you rent it for the period of time that you need, and then the people that owns the intellectual property of that model gets rewarded for the usage of that model. So it's kind of a democratization of AI, making it more accessible, having more competition, and making it more efficient over time. So people will be able to select which AI models they find more productive, more cost efficient, more affordable.
Yeah, sure. I think in the future, we are for enhancing this democratization in AI, we are going for building something like DAO in this space, decentralized autonomous organization, because we have to make sure everything's going based on the blockchain or Web3 based trilemma. And it's mandatory when I think about these AI types, they should be, for example, as an AI model or as a company that provide AI model, you can rent it out to another projects if they want or something based on this concept. We have to create the blockchain trilemma, decentralization, and also enhance the decentralization in this space.
Yeah, I mean, you can say DAOs have not yet been as successful as one has expected. There's primarily a reason is that they're difficult to use still. There has not been a DAO big winner solution. But yes, however, I do see that DAOs over the long run can contribute. You also have to have the regulation framework that actually supports DAO. So for example, here we have RACDAO and Ras El Hema. In the United States, you have Wyoming that actually supports also DAO infrastructures. DAOs are quite unique because they have something known as a governance token that allows you to vote and make selection of what specific parts of the organization are going to contribute value to the entire network. But I think over time, DAO will become more mature, and as it becomes more mature, you'll get more simplified usages of this technology. But today, I think it's still, we need to make a few more steps and for DAO to get more adoption.
So, if we think about this part, we already talked about the depin. There is a great combination in terms of subject, the decentralized science, because currently AI models and AI platforms are able and capable for learning every science that we currently have in the web. So it's very close combination with depin also as well, because the other side is cloud computing, AI models, and currently we have a decentralized science. What do you think about this combination?
I think decentralized science is just beginning to make its baby steps, but we have already had a few success stories. What decentralized science has been able to do, it has actually been able to invent new things that did not exist before. And the way they've been able to do that is by combining the information that exists or the knowledge from the accumulated information on the web, and then to make suggestions for new intellectual properties or new patents, if you want. So this is the baby steps. Does it have many applications? Of course it has. Discover new drugs, discover new treatments, discover new parts for cars, etc. But I think today we're doing the initial baby steps in the advancement of this technology. I think the big discoveries and implementations of this are still yet to come. But
Yeah.
the future looks very bright.
Yeah. I don't have, to be honest, experience in this decentralized science, as you mentioned. This is.
I can send you some
maybe-
examples.
Yeah. But what do you think if you're going for decentralized science? Definitely will change, and we have to make an adoption with this category. But what is your examples, and what do you think what will be happening in the future?
Well, I think the most important thing that needs to happen in the future, especially in relationship to AI, is the regulation of AI. Because every technology's got the pluses and the minuses. You can use for something good, you can use for something bad. And I think if we don't take care, then we can put ourselves at risk, like what happened during COVID or other situations where something gets out of control and then it's affecting our overall health. There's been a few projects that have been kickstarted. One is I can call it the reverse DNA or the parallel DNA project, which is kind of, I think it has maybe some benefits, but maybe the risks of starting projects that benefit, you can say the risks outweigh the benefits. So maybe we as humans are not ready to play such kind of risks.
AGI is coming.
Yes. AGI is another example. So I think there have been many attempts, but I think we're still a few steps away, but it's coming very, very fast. Advanced general intelligence. So maybe we'll have a digital twin of all of us here at the next doing a speech. I think yesterday we had a very good demo at the 1 Billion Followers Summit. There's a guy called Fred that brought his digital twin on stage and they were conversing with each other. But there's one thing that people found interesting is that the digital twin was not funny enough. So people felt that it was not human enough.
Yeah.
So it was too cold, too mechanical. So, but it's again, it's a part of evolution, and that comes with time.
Right. Cool. Yeah.
So it's been a pleasure to be with you today, and hopefully you enjoyed the discussion. I'm not sure if there's any questions from the audience.
I had a follow-up, maybe a topic, just on you were talking about renewables before, and it was so long ago that I didn't want to add another topic to that because I always wanted to get going. So, but maybe if we have time, just on you guys are talking about renewable energy, or let's say on the carbon footprint, and on the carbon footprint that generated by various cases, for example, cows. And most people don't talk about it because, like our industry, like civil engineering construction industry is, let's say, very old school, and we are one of the biggest, unfortunately, it's like
Polluters, yes, that's correct. It's the generation of cement. Most houses here are made with cement.
Yes.
Cement has a very big carbon footprint. That does not mean you cannot change. Today you can create new generations of cement that use a much lower carbon footprint. Actually, many construction projects have created very bad carbon footprint. I can give you a second example, which is from Canada and other parts. For example, we think that, okay, we're going to create an hydroelectrical plant, and that is going to be very good for everybody because we're going to produce hydroelectricity. Now, to generate a hydroelectrical plant means you're going to flood massive amounts of land with water, but before there was no water then. Guess what? When you flood that land with water, you're going to be producing massive carbon by flooding those lands. So you can say hydroelectricity also has a positive aspect, but also has a negative one. So I think when we're doing due diligence for all these projects, it's important to have people with open minds that actually study all the impact. And all the impact is not always plus, 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 and all rosy, rosy, rosy. There's always a negative impact, and sometimes we need to outweigh which approach to take. Even something today, we were talking a bit about cloud seeding and all that. Cloud seeding has a very positive impact where you generate the rain, but the rain that falls here will not fall somewhere else. So what happens to those people who don't get the rain? So you're just shifting some of the solution, but not necessarily solving the entire problem.
Also, as you said you have also heard about these ecosystems where you the best way to approach is also electric cars, for example. It's not that the electric cars are the solution, they're probably part of the solution.
They're part.
Yes, but they are definitely one part of the solution. It's not like they are bad or good, or petrol or diesel cars are bad or good. It's just you can't say we will abandon all, let's say, diesel cars. Like,
actually, you can't, because the cars that exist today are going to be good for at least 10 years, maybe 20. So even when you introduce a new technology, it's not like it takes effect tomorrow. It takes time to get adoption of that technology. Even with, for example, electrical cars, until the charging stations have not been deployed everywhere, you cannot drive. So you can only drive 100 kilometers or 200. So if you have to go 1,000 kilometers, then you have a challenge.
and the batteries that you have to recharge or recycle or the...
There's different generations of batteries. There's lithium-ion batteries that are very polluters because there's limited ion, but there's a whole new generation of batteries known as electrostatic batteries. They're basically capacitors. They're made from paper, so they don't pollute anything. Of course, they're not as efficient as lithium-ion. They need a bit more space and a bit more weight to produce the same amount of electricity, but guess what? They're completely disposable, they're very clean. So then again, it's to weigh the different technologies that we use and when to use the right technology to create a solution.
That's why I'm saying you can't, like, right now you can't get rid of one of these. You need to have them.
You need to have a balance, correct, and an ecosystem.
And to give that ecosystem a chance to develop, for example, electric vehicle. They could develop better, more efficient, more less carbon, let's say, carbon footprint creating solutions. Maybe, hopefully, who knows?
Back to you.
Very good, very good. Well, guys, listen, let's give Georgie and Pastor a quick clap. Thank you so much for
Thank you. It was a pleasure to be here.
Thank you so much.
Thank you, everyone.